So, have you ever asked an AI a question, a simple question, and gotten back an answer that was just completely made up? It's bizarre, right? Well, that phenomenon has a name, hallucination. And honestly, it's one of the biggest hurdles for AI right now. So, the big question is, how do we make these incredibly powerful tools more trustworthy? How do we tether them to reality? Well, let's dive into the solution.
All right, so here's our roadmap. First, we're going to break down this whole hallucination problem, why AIs get things wrong. Then we'll introduce the really elegant solution, which is called RAG. We'll pop the hood, see how it actually works, check out how fast it's evolving, and then, have an honest look at the challenges it still needs to overcome. Okay, let's start with the problem itself. These large language models, or LLMs, the engines behind things like ChatGPT, they are unbelievably powerful. But they have this tendency to just invent facts, and that can have some really serious consequences. And I'm not talking about some theoretical problem. I mean, look at this. When Google's Bard AI made a simple factual error about the James Webb Space Telescope during a public demo, the market reacted immediately. We're talking about a $100 billion drop in stock value. 100 billion. That's the kind of scale we're dealing with here. It just goes to show how critical factual accuracy really is.
So, it's a totally fair question. Why do these super powerful AIs just make stuff up? Well, a standard LLM basically operates from a fixed internal encyclopedia. Think of it like they crammed for a huge test at one single point in time, and that's all they know. They can't check the news, they can't look up new facts. They're basically working from an old map of the world. So when you ask about a new road or building, all they can do is guess where it might be. And this is where our hero, Retrieval-Augmented Generation, or RAG for short, enters the picture. If a standard LLM is stuck with only the books it's already memorized, RAG is the tech that essentially gives it a library card and access to a massive, up-to-the-minute external library of information. You know what makes RAG so smart? Is its hybrid approach. It combines a retrieval system, that's the part that acts like a research assistant, going out and finding relevant facts, with the incredible language skills of the LLM. So it doesn't just rely on its old memories. It actively seeks out current, authoritative knowledge for every single question you ask. This analogy just nails the difference. A regular LLM is like an ancient mariner, trying to navigate with a map that might be centuries out of date. But a RAG-enabled LLM? That's more like a modern space captain, navigating with real-time star charts. It checks its position against external, reliable data points before it plots a course, making sure the final answer is grounded in today's reality. Okay, so we get what RAG is and why it's so important. But how does it actually do it? Let's get into the mechanics and see how it goes from a simple question to a fact-checked, grounded answer. The process is actually pretty elegant, and it boils down to 3 key steps. First, you ask a question. The retriever part immediately springs into action, searching an external knowledge base, could be a company's internal documents, could be the whole internet, for info relevant to your query. Second, it takes that info it found and augments your original question with it. And finally, this new context-packed prompt is handed to the LLM, which then generates an answer based not just on your question, but on the fresh facts it was just given. And you can see the genius of the system right here. Your original question doesn't go to the AI all by itself. No, first the system retrieves these relevant chunks of information from an outside source. It then literally stuffs that information into the prompt right alongside your question, creating what's called an augmented query. This makes sure the AI has all the necessary context before it even starts to think, which is how you get a grounded, factual response. But wait, how does the retriever even know which documents are relevant? This is where the real magic happens. It's something called vector embeddings. All that external data gets converted into numbers, into vectors. So think of every piece of info as a star with its own unique coordinates on that huge star chart we talked about. When you ask a question, your question also gets turned into coordinates. The system then just finds the closest, most contextually similar stars to give you your answer. It's searching for semantic meaning, not just simple keywords. It's pretty incredible. Now, RAG isn't some old, static concept. It's a field that is having an absolute explosion of research and innovation. The core idea, which first popped up in a paper back in 2020, has since just branched out in dozens of exciting new ways. And this timeline really shows that evolution. I mean, it started with pretty simple keyword-based retrieval.
But the field moved fast, advancing to what's called dense retrieval, using those vector embeddings we just talked about to really understand the meaning. Then came the big step of integrating it with today's massive LLMs. And right now, the focus is all about making these systems faster, bigger, and more transparent so we can understand why they make the choices they do. And wow, this slide really captures that recent boom. Just look at all these different approaches to RAG, Self-RAG, Raptor, you name it. The absolutely wild thing is that almost all of these were developed in just 2023 and 2024. This isn't old tech, this is the bleeding edge. It's a frontier of AI that researchers are actively building and improving as we speak. Okay, but as powerful and amazing as RAG is, let's be real, it's not a perfect fix. It's not a silver bullet. It actually introduces its own unique set of challenges that researchers are working hard to solve, so it's important to have a balanced view. This example is a perfect, if subtle, illustration of where RAG can fall down. The system did its job correctly. It retrieved a relevant source, in this case, the title of an academic book. But it completely failed to understand the context of the question mark. It didn't get the rhetoric. It took the title literally and generated a statement that is factually incorrect. This proves that just finding the right info isn't enough. The AI has to interpret its context correctly too. And that's just one of several big challenges. The quality of what it retrieves is everything. You know, that classic garbage in, garbage out problem? Sometimes the AI can struggle to weave the facts it finds into a smooth, coherent answer. And of course, it's at the mercy of its library. If the data it pulls from is biased, well, the AI's answer is going to be biased too. On top of all that, these systems can get really expensive to run at a large scale, and sometimes they're still a bit of a black box, making it hard to trace exactly why it gave you the answer it did. So there's no doubt RAG is a huge leap forward in making AI more factual, more reliable, and more useful. But as we've seen, it also opens up these much deeper questions. It kind of forces us to reconsider the very nature of knowledge itself. I mean, if a machine can instantly access, synthesize, and reason with the sum of human information in real time, what does it even mean to know something anymore? It's definitely something worth thinking about.